plus, 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 plus. So that's pretty easy to understand. Now we have one problem here if we try to run this under Perl 6, and that is you will have a syntax error right there. Perl 6 has regularized the syntax. All of the arguments have to have commas. So we need a comma here. Let's add a comma. There's our comma. Now it is legal Perl 6, and it will run under Perl 6. Okay. What else can we do to this? Well, in Perl 6, we don't have to use @_. The arguments that come in, the way they come in Perl 5. We can have real parameters, real signatures. So we say sub RMS star says read in a list. We call it that Slurpee. Slurpee @nums. What else can we do? Well, this map. We write maps all the time, and it's a little bit clunky, a little strange, a little ugly. Can we write that more simply? What's really going on here? Map again is sort of saying take each of these elements of @nums and do this to each of them. And we'd like to think of @nums as an array object, and 2 as another argument, and somehow just apply the star exponentiation. We'd like to apply that directly to those 2 arguments. Well, we can do that in Perl 6. We have what we call a meta operator, x. X says take everything on the left and do an operation to everything on the right, or with. So in this case, there's only one thing on the right. So that says exponentiate to the power 2 all of the elements of @nums. And this is a very powerful way of doing many operations in parallel. And in fact, this sort of meta operator becomes very easy to run multi-threaded on a multi-core. You could run it on your GPU and it would go very fast someday. Not yet, it's slow right now. What else can we do? Well, okay. Variables are nice sometimes, but here we make a variable once and we use it once. That's kind of a waste. There's no really good reason to do that unless you really want to name the variable. Likewise, ints and ints, there's only one of each. So we can insert and substitute in each of those. And now there are no variables at all except for the parameter nums. And that's a lot cleaner. And once you understand what these 2 operators do, it's quite readable too. What else can we do? Well, why couldn't we drop those parentheses before? We couldn't because if we did, the new line would be an argument to RMS instead of to print. Well, but what if we change it to say? Perl 5 has say now. Say is a stupid function. Baka. But kapkoi. And so we can drop the print now because we don't have to worry about the new line. Come on! So we get the, this is the web page I was showing you before. Here are pretty much the examples of Perl 5 and Perl 6 here. There's a few differences. You'll notice that the Perl 5 example is using a statement modifier. So that's a way to get away from using both the brackets and the parens. And they still use the parens here. Also, you'll notice they use a plus here. They don't have to, but they're using it to be clear that we're using this value for a numeric value. In Perl 5, plus doesn't do anything. In Perl 6, it gives numeric context. So it takes whatever it is and turns it into a number. And you can see many of the other solutions on this page. There's the Oz one I was showing you. Oh, camel. What's the longest one here? Some of them are pretty long. I think the longest one is probably pure basic.
Wow.
A little bit longer than the Perl. Yes.
Of course, it's very commented.
Comments? Well, if the code is clear, why do you need comments? So, Perl 6 has been good for Perl 5 too. We talked about say. Perl 5 has borrowed, or should we say, stolen some features, but that's good. We have say now in Perl 5. We have smart matching, tilde, tilde. And using smart matching, we also get a switch statement, given when. Also, moose and Perl 6 objects are essentially the same model. So if you start using moose, you're actually starting to learn how to use Perl 6 objects. And in the future, Perl 5 may borrow more things. For instance, that meta operator like that might be borrowed. You have a binding operator. You haven't seen that, but you might have a binding operator, and that would be used instead of assigning to type globs. Type globs are bad. Binding is good. Maybe someday some of these other ideas that Perl 6 has might also be borrowed.
We're working on it.
Yeah. Some things that will probably never be borrowed are fundamental deep issues, such as the type system that underlies multi-method dispatch, and the way that context is lazy in Perl 6. In Perl 5, context is known at compile time. The compiler knows if an expression is in list context or in scalar context. In Perl 6, it does not know that until you actually use it somewhere. And it all works out nicely, but it's a very different model. Jesse, feel free to prove me wrong.
It's more convincing other people to prove you wrong.
Yeah, okay. So, return to Oz. Now, you thought this was maybe a little uglier than the Perl example. How about this? Yeah, I actually liked Ada when it first came out. Of course, I hadn't written Perl yet. It was a lot better than Pascal, but it makes you say a lot of things. You must say, with Ada float text IO, use Ada float text IO, with Ada numerics elementary functions, use Ada numerics elementary functions. I hope you like to type. This is another language where you have to put all your declarations at the front and then the code later. And inside, in this internal function, same thing. We have a function and a declaration of the sum. And just like in Perl, where we declared $R, that's the sum. And then we're going to do the same loop. It must be declared in front. You can't just put a my somewhere out in the middle. Now, here's something that's nice about Ada. You notice you don't have to have parentheses around the loop expression. Unlike C, where you have to have parentheses, and Perl 5, where you have to have parentheses. I like this. And in fact, Perl 6, you don't have to put parentheses around there either. You must declare the size of your array. Here it is 10 numbers big. And it must know the type of it. And apparently there's no easy way to say 1 to 10 as a data structure, so they have to list it out. 1.0, 2.0, 3.0, 4. And so they all have to be .0 too, because it's float. Otherwise it would be a type error. Now, it's been long enough since I studied Ada, I don't even remember what this argument does. But you will notice the fat arrow, we borrowed that into Perl. That's where that came from. Now Java also is in some ways quite similar. It makes you say a lot of extra things. Kolai. That's not kawai, kolai. Scary. First of all, I don't understand this idea of importing math. I mean, math is kind of universal. Everyone studies math. Why do we have to import it? Is this like, you know, Earthling math versus Martian math? Or I don't know.
Java math.
Yeah, Java math. And we have to put everything in a class. Why does it have to go in a class? Because it's Java. And then the first thing we do inside the class is say, oh, we didn't really mean it. These are just more like functions than methods. So we have to say we're in a class, and then we have to say, oh, never mind. Everything must be strongly typed. Sometimes that's good. It does make it possible to optimize sometimes. But another difference here, you notice there's no my. There's nothing to say I am declaring something. You just put a type first, double. So if you put a type first, that serves as the declaration. You pretty much have to do it that way. Okay. Again, here's a language where you have to put parens around the argument to the loop. And in this case, it's a C-style for loop with 3 arguments, which is kind of clunky. Does Java have ++ yet? I don't remember. Anyway, they're using +=1 there instead. And they're using indexes. Rather than just being, I think Java, they're adding a for each, right? But that's new. For a long time, you had to write it like this. There was no way to iterate a list. Again, you have to tell it. I mean the square root that comes from math. What other square root is there? I mean, unless you're Donald Duck in Math Magic Land. You have to tell it system.out.printf. You don't have to say that in C. Why do you have to say system.out? That's just waste. Again, 1.0, 2.0, 3.0, 4.0. No way to generate the list.